Cool. 936 stamping the sequence. You want to form a target string of lowercase letters. At the beginning, your sequence is target.length question marks. Okay, you also have a stamp of lowercase letters. On each turn, you may place the stamp over the sequence and replace every letter in the sequence with the corresponding letter from the stamp. You can make up to 10 times target.length turns. For example, if the initial sequence is 5 question marks, use Java like a real man. I mean, heteronormative terms aside, I could change languages. I could use Java. I could use C++. I do actually take languages requests, but yeah. For example, if the initial sequence is 5 question marks and your stamp is ABC, you may make ABC question mark and so forth in the first turn. Okay. Assembly? Well, okay. Any reasonable language. That'll take me forever. Actually, I mean, I take some requests, but not. Yeah, let me finish reading this. If a sequence is possible stamp, then return the array of index of the leftmost letter being stamped each turn. If the sequence is not possible to stamp, return an empty array. For example, if the sequence is ABC and the stamp is ABC, then you could do it in 2 turns. Okay. Also, if the stamp sequence is possible to stamp, it is guaranteed that the possible stamp within 10 times n moves. Any answers specifying more than this number of moves would not be accepted. Okay. Okay. Huh. I guess the order does matter. A, B, C, B, A, A, B, C, B, A. So in this case, okay. I mean, I'll do Java. Let me play around. I mean, it doesn't really matter for me. Cool. I'm just reading this poem. I mean, I haven't started coding anyway. Okay. So you would start at the 0, 1, 2, 3. So you get the last, you get the 2 prefix. Okay. So n is equal to 1,000. What does that mean? I think my thought process is that going through a couple of I mean, is going for a few things. I'm thinking of a sort of dynamic programming where, but I think I have an n cube dynamic programming that's pretty straightforward, but but obviously for n is equal to 1,000, that's not going to be fast enough. We'll have to get slightly faster. Don't think I have a great first intuition about this one, but I think as kind of the example 2 stamps out, if you will, greedy is not going to be sufficient. Well, that's not true. I think one thing that it seems like you want to do for this problem is that you want to get the edges and then you lock them in. So from that, is that enough to have a dynamic programming solution? Because from that, you have 2 choices: stamp at the left or stamp in the right, and you could do that in all of. I mean, that's just all of 1, but there are all of. But that's but there is all of n kind of cars in the prefix in the copying. But in that case, each character will be only looked at once anyway. So maybe that's not actually n cube, even though it is similar, because you want to because your offset will be to yeah. Okay, I think so. That's probably okay. But then now you have to do the path reconstruction uh, part of dynamic programming. It's either there or there's something like really obvious about it that I'm missing. Uh, but yeah, because this is actually not deterministic per se, or like it doesn't have to be. Uh, okay, am I ready? Okay, I mean that took me 5 minutes just to read the poem and think about it. But yeah, okay, I think that's reasonable. Let's actually okay. I have to remember some Java syntaxes for certain things, but oops, definitely not that. Mm, I don't need the public actually. Mm, I want to set the DP to oops. Maybe end by +1, but it should be okay. Let's just say, oops, T. Okay. What is this indentation weird? Okay. So now, well, we need the similar thing and to later do path reconstruction. So we have to do this again. Also, I am a little bit new to Python. Well, I haven't done Java in like I don't know, in a long time. So always welcome feedback on writing more or better Java code if you have a thing for it. Yeah, let's actually go through the way. I guess I could have done this here actually. Why is this indent so weird? Um, I guess actually we don't need the min move. It just wants any possible way to stamp. So actually, maybe I don't need dynamic programming. I mean, you could use dynamic programming, right? But actually, what it wants is just any moves. Hmm. Yeah, right now I'm just thinking whether because I actually don't need min moves, so I could think about I don't know, other strategy that doesn't take min moves that are maybe a little bit greedier, but easier to implement. Um, I think the observation is that we can always take the prefix and the suffix and then make them smaller, but that only maybe is the case if there are things in the beginning. Well, in this case, we could just be greedy and then and it's just stamp from backwards and then forwards. Like in this case, we could stamp the entry at 1 twice, for example. But I can't guarantee that in the worst case it won't be big enough. But yeah. Do I want to do DP? Okay. I guess I don't actually need dynamic programming for this one because we're not trying to find a min. I think what we want to do is then so it's only possible if the stamp yeah. So we could work our way from inner out, if that makes sense. We take this and then we cancel it, and then now we're trying to do the prefixes one by one, and if you could always do it, then well, I mean, I guess it's guaranteed, but in theory, it will only do each like for a string of length n, you would only do each cell once. So okay, yeah, I definitely just have. I forgot to. Usually, these kind of problems they ask you to do the min, so I forgot that this one may be easier for that reason. Now to remember my thing. Okay, so let's start with. Okay, so that we could have yeah. How does this work? Just like a. Can I use a vector? Is that a no? But what is the how do you get a generic array? I guess I do not know. Okay, I'm going to do this in C++. I don't remember the generic classes. Sorry, friends. Try better for next time. Cool. Okay. Let's just say I think that's the results. I mean, I hope that me doing it in C++ is close enough to Java. I just don't remember all the. So when I used Java, it was before generics like Java 1.3, 1.4. So I don't remember I was about to use vector in Java, which apparently is not generics anyway. So that's where I was at, and then you have to do like some conversion back and stuff like this. But it's not a big deal. It's just been a while. Cool. But yeah. Oh, well, I could also do it in Python then. Fine, let's do it in Python. Same. I mean, most of the code compiles in C anyway. Okay. Oh, is equal to an array, and then return results. And then now, let's just do a sort of greedy by the inwards out. How do we mark it? I guess it's like almost n squared, but yeah, cool. Now, I enjoy writing Python. It is very easy, relatively, but it's also easy to get in trouble sometimes with performance as a result. But okay, full x. Just do while true. I guess let's get the initial pass first. That is if stamp zero target. Oh, I think I confused the two, but okay. Actually, what is the target? X plus n. You're going to stamp. Maybe I lied. Maybe C++ would have been faster because I could have maybe done some math with the matching. But okay, then let's just okay. Actually, I'm going to do C++ because I think it's easier to change the way. Yeah. Oh, it's okay. And technically, these are unsigned ins, but yeah. We want the target. Yep. So starting from I, we want to check where the okay, if stem dot of from I to this autocomplete thing. It's kind of fun. I forget if it's this autocomplete works half the time. Okay, is it size or okay, fine. I always forget if it's size or the length for the second parameter on these, but Alright, let's just do a check. Also, I mixed it up again. I guess I just print out the I. No, I don't print out anything. That's a little sad. Alright. Okay. Missed one thing. Okay, so at least that's right. I guess I need this. Okay. So then now we do want to, if that's the case, we do want to stamp it here. Okay. Just I'm trying to figure. Okay, I don't like autocomplete. Okay. What's a good way of programming this? But now we want to, from that, we want to stamp going to the left and to the right. And then just do it that way, and then that'll be over n time. Okay. So let's say, so yeah, let's just do left, right. Left is equal to, well, I, and right is equal to I plus n, and we break. Okay, let's set these to -1, just for fun, but we can also just do if size is equal to 0, then we can return an empty array. Okay, just return. So that's when it's, because it's not possible, because your last stamp will have to have the target as the substring. So if you don't have to, or sorry, if this, you have your last target string will have to stamp as the substring. Otherwise, then it's not going to work. Otherwise, we will expand outwards. How do we do this in a good time? I think about maybe rolling hash, but maybe that's too complicated. But okay. So now your left is at I, and you want to check. Okay. Wow. Left. I think now we could just do greedy from the left, actually. Just stamp on the left, and then and until you get to left. Okay. So let's just do for in I equals 0, I is less than left. Yeah. Then we won't keep track yet, but okay. What are we doing here? Okay, so from here, let's match as much as target as possible. Okay. Is there push forward? Okay, let's just have a last then. Let's just push this back. Okay. Now let's just match as much as possible. Well, I guess we have to, so if what's it called? Target sub I is not equal to stamp sub 0. Well, that means it's not possible because of what you call it, induction. Otherwise, we press, print right now, and then just move forward. Well, target sub I is equal to stamp sub 0. Well, it's just I. No. Okay, I guess I need a while loop. For in j is equal to 0, j is less than n. If sub j So I plus j is not equal to stem sub j, we break, and I is equal to I. Yes, that's okay. Except for that, we also want to increment I on everyone. Oh no, well, we kind of do, but I'm writing this in a really weird way. There you go. Okay. So we only take into account the left, but I just want to see whether that would get me close enough. Do I have to increment otherwise? Okay, that actually is surprisingly refreshing. I mean, I do expect this to be wrong, however. But let's see if the way it is being wrong is consistent with what we expect from it. Okay, because we don't consider the right side. So we do press the 1, which takes the middle, and then we press at 0, which is okay. Okay, let's get a little bit more of a prefix thing going. So then this should press at first 2, 3, 4, and then again 5 here, and then here, something like that. Okay, I mean that's roughly how I mean these expected answers don't really mean anything in this case because you have multiple algorithms, but I do expect that to be how to print, so or how to stamp. So okay, so now let's look at the right side. So we have to do it backwards where I is equal to m minus 1. Yeah. 1 I is maybe something like this. Could be off by 1. I have to think about it. But the same logic going the other way. Push back up. Yep, that makes sense. And then now, is that enough? Well, let's see. I still would like this case just for testing purposes. Well, that's not great. Well, yeah, because this has to be minus minus. So of course it would go on forever until it goes out of bounds. Like there's also something else. Oh, this is n. Confuse my n's and m's. In this case, this is also n. Yeah. Is this a heart? It was a heart. Oh no, wrong answer. Wow. Well, to be fair, I should never press 6. So I think this math is a little wrong. It should be I, but I minus the size of stamp. So something like this, maybe even minus an additional 1, because maybe this is off by 1. Right now I'm a little bit, lazy, so I'm gonna do that. Usually I would probably do. I think I is right. Yeah, maybe it's this. Because you want to press at here, which is the third spot. Okay. Yep. Cool. Like I said, oh, my answer's short answer, but that's fine. Do I have any edge cases to think about before I try to submit? Length is at least one, so let's try that. Oh no, I guess the stamp is always smaller than whatever. Okay, because that was the thing where I may have a weird issue. Let's try for one more. Okay, cool. Let's YOLO this. Wouldn't be surprised if this got wrong too. There's a lot of weirdness about this. Yeah, oh, whoops. Okay. Why do I return empty? I mean, that looks like a thing that I would not return empty on, but okay. Interesting. Okay. Okay, I guess this is one of those times where maybe I could use the debugger. Ooh, I just have an off by one, to be honest, somewhere, but because yeah, okay. So I do hit this where I is 6, stamp is D, target results 0, 8, and 7. 0 is 8, I don't know, somewhere down there. Okay, empty is just empty. So, okay, N is 2. That makes sense. So it looks at what is target sub I? I is 6. Target sub I is 0, 1, 2, 3, 4, 5, 6. It's a D, so D is not equal to E. Oh, I have to do this somewhat recursively, I guess. Okay. Okay, I mean, I think that's actually a reasonable bug that I had. I just kind of had it one level, but you have to kind of do the same idea, but kind of recursively so that you kind of expand from these middle pieces. Okay. Cool. Because you want to expand from this TE instead of this TE. Because from this TE, then yeah, you move across here, and then it's just going to try to do this last, but you want to do this one before this one. So okay. Okay, I think I have another way of doing it, but that which is why I didn't see, but I changed my mind a little bit. Okay. Okay, fine. Right now I'm just thinking about how to kind of, well, incorporate this in a good way. Definitely want to do this. It doesn't work anymore. Maybe we don't have a left and a right because, well, there'll be multiple of them. So we want to hold the state of maybe like a Boolean state of, okay, fine, let's do that then. Of, was it of size of target? Okay. Used is you. I'm gonna do. Oh yeah, I forgot. Okay. What's up, Virgo Studio? How you doing? Use sub I plus J is true. And now just the results that push back of I. Okay. If okay, now coming from that, we want to just keep on doing matching, I suppose. And we want to match so that, and if it's used, that's okay. We consider that part of the part of the matching because that means it's going to get stamped over. Okay, fine. So then now let's just have a while true loop. Just going changed. Oops, was it N or M? M. Okay. Bye-bye. Was fun knowing your code. Okay. Now we have to do if. So that means if. Yeah, okay. I was going to say you can only start from something, but I guess that's actually not true. So, okay, if target sub I plus J is equal to the stamp of J, or the I plus J is already used, then we continue. Okay, and so that's a good thing. Otherwise, brick. Okay. Yes, I could just use the De Morgan's law, but okay, fine. I am over lazy to use De Morgan's law, so okay. If match, then let's push back this I, and also let's mark this off. And also because of the way that the size of the stamp is constrained, you can only go left or the right. Like you can only stick out one side or the right side and not both sides because your previous stamp has to be the size of the stamp. Okay. I think one thing that I want to check is that we don't do the trivial case, so we should at least okay. So this so that means we want at least one new count that's unused. Otherwise, that's just not great. Bool once 0 4s. That's just that reminds me of that movie Once. Great movie, by the way. Definitely recommend it. If it matches and we use at least one character, then we push back some stuff, and then also change it to true, so we keep this loop going. Change it to false. And also set order j to be used. Oops, that's not my. Well, I plus j is equal to use. Yeah, and then now. And now we actually want to break out this loop just because why not, and then go start the entire loop again. Though I think maybe it doesn't really matter, but I think this may be reversed. I need to reverse my my results. Whoops. So this keeps on being true. Oh, I guess this is actually and not used, so that you get one new letter. Whoops. Okay, I mean that was good, but we definitely have duplicates, especially right after each other seems unnecessary. I mean, I'm okay with duplicates, but why is that? Oh, I think that's. Why do I have duplicates? Well, I mean, I understand why I have duplicates, but why do I have duplicates so, like, dumb? Okay, so I mean, just to do. You said used to be true, right? So, it seems like it still will be okay, but let's comment out this part and then see if this loop it's okay. I guess I didn't actually even need the beginning for it now that I think about it, other than to set that up. 68630. Okay, I mean. So the other, because the reason why this code doesn't work by itself is because it doesn't have that precondition of everything matching at least once, but it doesn't seem like it matched this 1. And this matched to 1, but do I do this twice or something? Why is this judging so slow? So this does push back the same thing twice, do I might being, oh man, I am silly. I have this inside the loop when I mean it outside the loop. Okay. That could actually have cost me a wrong answer, just from what you call it, pressing the same thing more than 10 times because the size of the target is big. So I'm glad I fixed that. That was a silly mistake too. Let me make sure that I do it correctly on this side. Okay, maybe I do. Okay, let's run it for order test again, and then hopefully submit again. And that's not true, right? So it wasn't a few seconds ago. Okay. Let's see how long it took for me to fix this. Oh no, okay. Huh. Oh, I did meant to check one last. Oh, okay. I think I rushed it at the end, even though what you call it, even though yeah, even though I was slow, I still kind of took an extra thing to double check, which is unfortunate. But I mean, it's a easy check. I thought about this while writing the code, but then I just forgot about it. Which is sad. It's such an obvious thing, but I mean, one of my goal for sure is to be more deliberate, meaning almost ironically slow myself down so I get more correctness. But clearly this one I didn't quite work out that way because I could just this wasn't obvious. I mean, I even talked about getting edge cases, so that was just silly. Okay, cool. A little bit on the slower side because I think I don't know. You could probably take advantage of some of the similar sub problems, and cool. Okay, how long did I end up taking? About 45 minutes ish. Cool. Yeah, I mean, I think this was I mean, it's a hard problem. I don't know if I would have done better if I tried it self with dynamic programming like I tried to. Would have been okay, maybe, but maybe a little tight on the timing. For n is equal to 1,000, I think if n is 100, I probably would have done dynamic programming, but it doesn't require you to do the min, right? Just any solution. And I think I'd end up choosing some sort of greedy. I think the thing to kind of the key note on this problem is to note that you know well, working backwards, right? From well, you know that if there's a substring in the target, yeah, the substring on the target that's the stamp. Well, then you want to save those last, right? And then from that, you could grow kind of the prefixes and the suffixes from that, because you know that the the pieces that are not equal will get stamped over and so forth. So yeah, definitely a little bit tricky, and coding isn't easy either. I made a couple of silly mistakes. It's only 15 minutes to get from my first wrong answer, but yeah, overall, yeah, in terms of complexity, just going over that real quick. Given n, this is going to be n square because this change variable will only be changed about n. Yeah, can only be changed n times. I think I did a little bit. The way I would do my for loop actually now to look at it is a little clunky, which is why the submission time is a little bit slower than most people do. It's still at a reasonable 128 milliseconds, but and the reason is because I changed early. I think you can do so. For example, this piece you can, if you're really slick about it, you can do one of those O of n string matching out or string substring algorithms, and that will reduce this to O of really O of n square. The way I did it is probably actually closer to n cubed in the worst case, but not easily possible the way I did it because of early termination and stuff like that. But technically, it's n cubed. But you can, again, with a good string matching algorithm, you could get this down to n square. Space, you're always going to be output sensitive. Like your worst case output is always going to be O of n's, or sorry, m in how I use it. So you can't really do much better than that per se. Though if you want to be output size sensitive, perhaps you can be slightly better. But I definitely use a lot of O of m stuff here, like the bull vector, and I guess that's it actually, really. But But yeah, overall, a very tricky problem for both an interview and competitive programming, at least for me. Uh, I, I would categorize this as an ad hoc problem, maybe even a little bit of a greedy problem. Uh, except for that, it's a little bit weird to call this a greedy because greedy doesn't always yield the optimal solution for this, and it won't for this problem. It's just that it is one solution to the problem where this given problem has a strange case where strange constraint where you don't need the optimal answer, you just have to be 10 times n moves. To be honest, I don't know if I've seen someone like that similar to on an interview. I feel like I mean, I think the closest thing that's similar to these kind of problems in an interview is kind of like when your interviewer asks you for like a some kind of exhaustive search thing on a thing that is like NP complete or NP hard or something like that, and you have to kind of focus a lot of talking through why. So this is technically not greedy, though. One of the solutions that meets all the criteria is greedy. So in that case, I don't feel like I feel like in general, other than exhaustive search problems, as I mentioned, I rarely see any open-ended problems in interviews these days. At least in terms of uh, um, the problem solving, the algorithms part. I mean, like obviously, system design is where they'd have all the open-endedness in general. So, but yeah, so I don't think I would like. I mean, there are components of this where it is useful. Like if you want to say dynamic programming or greedy, they're both they're both algorithms that will come in handy for interviews. But I wouldn't say this is a good practice problem for either of those algorithms per se. Well, maybe dynamic programming, but maybe not this problem because the n is too big for dynamic programming, perhaps. But yeah, overall a fun problem. Definitely, I could have been slightly better. I think in the same kind of comments that I gave for this problem, the reason is that I think, yeah, I just have to kind of almost like this is a ad hoc problem where you have to kind of think outside the box a little bit. It's not, like you're not restricted by some of your problems, except for maybe you could say that I could have used like a string algorithm, one of those linear time string algorithms for part of the matching. So that is a little bit algorithmy, but otherwise it's very ad hoc, very one-off. And for that reason, it's hard to kind of train for, right? Except for kind of getting a better intuitive sense of your current algorithms and kind of what they can do and bounds and kind of the properties of the problem with like prefixes of strings and suffixes of a string, which is something that this is not, I don't know, not something that's easy from this problem. So but yeah, at least in terms of practice, but otherwise still a fun problem, don't get me wrong. I enjoyed it because it definitely forced me to think a little bit outside the box. But yeah, before interviewing, I would maybe work on other problems first. That's just most hard problems, I suppose. But yeah, cool.